Hey guys, this is a short video explaining the image intensifying system, which is composed of the image intensifier tube, but you also have the X-ray generator and the TV system, which is the rate limiting step in your resolution. The image intensifier tube has a resolution of 5 line pairs per millimeters, while the conversion to the TV system degrades that image to about 2 line pairs per millimeter. Again, this is a classic C-arm. The X-ray generator is located at the bottom. You should be able to identify the two different components of the C-arm. And now we're going to focus on the actual image intensifier tube. For the purpose of this video, you should already be acquainted with the process of X-ray beam generation. So we start with that as a given. We have the X-ray beam that's generated and we're emitting it towards our patient. In this case, our patient is Dr. Bouchon. Then we have the first layer of the image intensifier tube, and that's the input phosphor. It is made of cesium iodide. This generates light photons. Then the light photons will hit the photocathode. At the photocathode, we have the photoelectric effect, and this means we will convert the light photons to electrons. Remember, X-rays are still photons, so we went from an X-ray photon to a light photon, and then we converted that light photon to an electron by means of the photocathode. And this is the overview of our image intensifying tube. We have the first layer in blue here that represents the input phosphor. Then the red layer represents the photocathode. In addition to that, after we generate the electrons, we have the focusing plates. Those focusing plates are negatively charged in order to repel the electrons and guide them towards the anode. The anode will be positively charged. You also have the output phosphor at that level, and the positive charge is pretty high. It's 10 kiloelectron volts, and the reason for this is that we want to accelerate the electrons generated through this potential and therefore gain energy. By gaining this energy, we will produce more light at the end in the output phosphor, and in the output phosphor we convert the electrons from electrons to photons. So we go back to light emission, and then this light emission will be brighter, and that's the emission that is recorded by the camera and then sent to the TV system. Therefore, by this potential, assuming we have a phosphor that's 100% efficient, which is really not the case in reality, but approximately you would be producing 10,000 electron volts and yielding 3,000 light photons. So there's a significant magnification going on here by as a result of the potential that we generate through the acceleration of electrons towards the anode. The image intensifier, then, it's important to realize that it creates an increase in brightness. This increase in brightness has two main components. The main components are the component that I relate to the intensity, so that's the electronic amplification, the electronic gain, or the flux gain. All those are the same, different terms for the same phenomenon. And then you have the second component that's more data. What I mean by that is that you have the data from the input phosphor, which, let's say we have a 10-inch input phosphor, then that's displayed at our output phosphor, which can be a 1-inch output phosphor, and that creates the effect that we have the same amount of data now in a smaller space, and that creates that minification gain, or that increase in brightness. So both geometric gain and minification gain are the same. They're just different names for the same process. I just gave you here a small example of the formula. So we have 10 squared, which represents my input phosphor, over 1 squared, which represents my output phosphor, and that gives you the measure or the calculation for the geometric gain that you generate as part of this process. In conclusion, you have a total increase in brightness that's created at the image intensifying tube. That formula is given, or that total gain is given by the electronic gain times the geometric gain, and that's how you calculate the total gain due to the image intensifier tube.